Just now, we will do together the first hands-on with a really simple. So you can do it at the same time if you have the same tools. If you want, you can do it later by your own after the session. The purpose and the goal of this session is to use an example provided into the firmware of the U0 to show the capability of all the low power mode available on this new U0 product. So we will begin by run this example on Nucleo U083, okay? And we will see together after how we can measure the consumption for low power mode with the STLink V3 power that Marco introduced just before. And we can also measure, verify that the consumption we will measure is aligned with the consumption mentioned in the datasheet of the product. So first of all, we will open the example and run it on Nucleo. So just to mention, for this example, I will use the firmware, the version 1.1.0 that will be available next week. On my side, I have this firmware version in advance to be able to show you in this workshop. But on your side, you'll be able to find it, and it will release next week. So we'll open the project from the beginning, and I will explain you some details. So let me open CubeMX, okay? So basically, when you want to use an example available on our firmware, on CubeMX, you just need to click on Access to Example selector, and it will open a window on which you can, you will be able to select the product you will use, and you can see the list of the complete example available on the tools. So let's wait a few seconds that it will open. Okay, nice. So on this window on the left side, on my side, I will use the U0, okay, and the Nucleo 83, okay. And now you can see in the middle of the screen all the example available for different peripheral. So in our side, we'll use a power example, and especially the power mode selection here. So just need to double click on it, and it will open a pop-up window like this, okay? And you be able to select your favorite IDE. So on my side, it's STM32Cube IDE, of course. And just need to install it. So on my side, I've already it, so I need to overwrite it. Okay. And after a few seconds, it will be automatically open Cube IDE with the project. Cube IDE is open, and I will show you some most important file on the project. So you will see on the left the project will import in Cube IDE. So the most important for me, of course, in the user, you have the main file. Okay, so it's obvious. So the purpose of this example is to use the UART connection between the laptop and the Nucleo to be able to print and to display the list of all the low power mode available on the U0 into a terminal. And by using this terminal, we will able to select the one we will run, and to measure the consumption of the specific low power mode. So in the user folder, you can see the console.c file. Here you can find the basic configuration and the use of the UART communication to be able to print all the information into the terminal. This function, the UART function, to be able to select the mode we wanted to use. And for me, the most interesting part is in the system_config.c file. And inside it, you will find all the configuration for each low power mode. So you can see here some different low power mode, system low power mode S10, S11, number 8. And for each, you can have a specific configuration. For example, here I'm in the system RTC config. So that's the way that the RTC will enable by code. If you scroll down, you can also see different system clock config with different frequency. And for example, last one, the system RAM retention. So if on your case you wanted to use the RAM retention, you can have some example to how to do it. Okay. So now we will build and flash together the example. So I already plug my Nucleo board to my laptop. Okay, so now let's build the project. Now, okay, all is good. So 0 error, 0 warning. So now, after plugging your Nucleo, you need you can directly flash and run the application into the MCU. Select the default debug access. Perfect. And normally, you will see when the program is flashed, the STLink LED here just blinking between red and green. Okay. And now, normally, it's good, and the application is running into the STM32U0. So to verify it works correctly, we just need to open a terminal and to connect in a serial port to our Nucleos. We just need to select the right baud rate. Okay, normally all the rest will on the default mode. Okay. I will restart the application, and okay, here I can see all the low power mode available that I can select. So you can see run, sleep, LP run, LP sleep, some stop mode option with different settings with the RTC or not, the standby, as the stop with the RTC, and for the number 3 with the SRAM retention available, and the deeper one, the shutdown. So now our application is running into the Nucleo. So let me come back in my presentation to introduce the STLink V3 power and the way that we will measure the consumption. The STLink V3 power we will use to measure the consumption have several range that will change automatically to have the best acquisition, the best accuracy as possible. So we'll able to measure current consumption from a few nanoamp to 500 milliamp. And you can see just a table from the datasheet that show you the accuracy depending on the range used by the STLink V3 power. So it's a good development tool with a very good accuracy to test and to verify your consumption for your application. So now I will explain you how we will plug the STLink V3 power through the Nucleo. So basically, on the STLink V3 power, you have 3 connectors: the out, the ground, and the aux. And the out will be very useful because by this connector, you will supply the MCU and measure its consumption. So it's very important to focus only on the MCU consumption and to not focus on the whole Nucleo board, but only on the MCU. So to do it, basically, we just need to remove the jumper number 5 just in the center. Basically, is the link between the VDD of the MCU and the 3V to 3 of the whole Nucleo board. And we need to plug the out connector of the STLink V3 PWR to the VDD connector. So it's the left pin of the jumper number 5. Okay. and basically link the ground to the ground, okay? We also need to remove the jumper 9 just here with the link for the end reset signal between the internal STLink of the Nucleo and the MCU. And if we don't remove this jumper, we can have some overconsumption. And the last point is on this specific example, as we will use the USB-C cable to be able to use the UART communication between the Nucleo and the laptop, we will have two ground reference in the same board. So one from the STLink V3 power because we supply the MCU with it, and one from the USB-C connector because it is linked to the 5-volt of the laptop. So the limitation here is, for example, I take the measurement of the standby, and with this configuration, we have an average consumption of 25 microamp, which is very, very high for the standby. So the workaround we will use on this end zone is simply to, when you will measure the consumption, is to unplug the USB-C cable. So by doing this, you will remove, you will have only one ground reference in the board, the one from the STLink V3 power, and you will see by this way, you will have the real standby consumption with near 135 nanoamp. So normally all is good. So let me doing this job in real time. So I unplug the jumper 5. Okay, plug my out of the STLink into the VDD, the ground to the ground, and don't forget to unplug the jumper 9 here. Okay, so now I'm ready to run the application and to measure some consumption. I put on the slide for each low power mode recap of what is available for your application, depending on low power mode you are. So basically, in run mode, all peripheral, all clocks are available on the MCU. So not very interesting for this end zone. Very quickly for some mode, because you can find it after the presentation on the slide. So basically, the low power mode, run mode, with quite the same as run mode, but you can see here we don't use the main regulator. We will use only the low power regulator to decrease the consumption. We have also the sleep mode. During this mode, the cortex are sleeping. We have also the low power sleep. As the low power run, we have only the capability to use the low power regulator to decrease also the consumption. So we will measure on this end zone, the first example, the low power sleep consumption. So as it will be mentioned, it was mentioned on the previous slide. In this mode, the cortex is sleeping, no access to flash, to SRAM, where some peripheral who can run. We will use only the low power regulator. And from the datasheet, the consumption target, the average consumption target is near 60 microamp. So let's try it in practice. With the software, we'll use a link to the STLink V3 power to be able to measure the consumption, and also the most important part, to supply our MCU. So now we have QMonitor open. So basically, I just need to select the STLink V3 power here to take control, and you will see when I take control of the STLink, this window will appear. So you can have access of some configuration for the acquisition of the consumption, the sample frequency. So I will use IO1, okay. The acquisition time, I will use the infinite loop. And as STLink V3 power, we will supply the MCU. You can select here the input voltage you wanted to use. So on my side, I will keep the 3V3, okay? And now I can power on my product, and you will see normally the out LED turning on in green. So I click, and okay, out is in green. So my MCU is supplied and the application is running. So I can start the acquisition, open again my terminal to select the low power mode I wanted to use. So we will use the low power sleep number 8. So I just need to enter 08 on the terminal, and you see your system low power mode configuration is as follows: power mode, low power sleep. So we see on the Cube monitor the full range of the low power mode. On this window, you can tap on Show Report here, and you will access to the full window average consumption and the select time frame average consumption. That means that you can select only the part you are interested by. So on our side, only the low power sleep here. And you can find here the average consumption of this low power mode. So 54 microamp with very near the consumption target, a bit better. So that's the way you can measure and evaluate all the low power mode. So maybe we can do another, some interesting one. So let me continue on the presentation. So after the low power sleep, you have the stop one. In stop one, some peripheral in light pink are frozen, so you can't use it. Of course, not all the clock are available. The difference with stop 2 is in stop 2 you are less peripheral available. I forget to mention on the right side on the slide, I put all the wake up event available on each low power mode. And here are the standby mode with very interesting some cases. On the example we will use, or we are using, sorry, 3 standby mode available example. One with the SRAM retention and the RTC, one with only the RTC, and the last one with nothing else, just the MCU in standby mode. So it's very interesting to perform this test to see the impact of each option, like the SRAM retention or the RTC. So for example, on my side, I will run the first one, so the SRAM retention with the RTC in standby mode. So as I show you just before, I just need to restart the application. Okay, so we'll use the mode number 3, standby plus RTC plus SRAM retention. So I will tape 03. Okay, nice. And now I can start the acquisition, and you will see on this typical example, because we are in deeper low power mode, the noise, because we are 2 ground reference, so don't forget to unplug USB-C cable here. And now we will see the right consumption. So let me select the interesting part, okay. And you will see the average consumption here with very near the target one on the datasheet. So here. So now I will run also last example. So without the SRAM retention and without the RTC, so just the standby, and we will compare the results. So don't forget to plug again your USB-C cable to select the low power mode you want to run. I restart my application and I will select the number 1, the standby. 01. Now the standby is running. I unplug my USB cable and start the acquisition. Okay, and here you can see the average consumption is 128 nanoamp. So let's verify with the datasheet value. So the datasheet value is 135 nanoamps, so it is really quite the same. So it's good. Okay, and the last one, the deeper one, the shutdown. So your RTC is still available if you want or not. And I don't put slide on VBAT because it's particular mode. So VBAT is when you are no supply source anymore, and you have a battery or supercap plug into the VBAT pin to keep some critical data into the backup register. So that's all from my side. So we have seen in this first hands-on how you can use the Nucleo U083 to evaluate all the low power mode available on the U0. So you can play with it by your own with the STLink V3 power if you have it, or if not, you can use, of course, NIST tools to measure the consumption. So you are free to play with it and to evaluate all the low power mode. I will, of course, share the whole presentation with all the details for each low power mode and for each example, low power mode example in this mode selection example.